So let's go ahead and look at an example walkthrough of FTC Part 1. So the velocity of a car is given by the function v of t equals t squared, where v of t is in meters per second and t is in seconds. The car starts at time t equals 0. The function s of t represents the position of the car at time t, and that's given by the integral of v of t from 0 to t. So you can see that is all written out here. Now, our goal is to find the velocity of the car at time t. So again, remember we're given the position s of t, and we need to find the velocity. So in order to do this, we're going to apply the FTC Part 1. So basically it tells us that if S of t represents the accumulated area under the curve, or specifically in the context of this problem, that's the position function of the car, then the derivative of s of t is going to give us the original function. So s of t, which is right here, is equal to the integral of 0 to t of x squared dx. And in order to find the velocity of that, we're going to differentiate s of t to basically get s prime of t, which we know is equal to v of t, which again is equal to t squared. So, tying this all together, therefore, the velocity of the car at time t is v of t equals t squared, which is basically just our given velocity function. So basically, this shows us that inverse relationship that we're talking about, right? So when we take the derivative of the accumulated position function, we just get the original velocity function. So to wrap things up, again, FTC Part 1 shows us how differentiation and integration are inverse operations.